I thank the Council on Tall Buildings and Urban Habitat for the honor and for the recognition. When I reviewed the list of the previous recipients of this honor, I was thrilled and quite surprised to have been invited to join such an illustrious group. I'm also delighted to see Les Robertson, who is here today. Some of them were my mentors, Richard Tomasetti and Charlie Thornton, and others, Peter Irwin and Clyde Baker, were professionals that I relied upon and respected, and they guided me with their expertise. So I thank them, my colleagues, and my partners for the opportunities that they gave me. So opportunities, it's something that Larry mentioned quite a bit also. Opportunities can make the difference. Let me get myself moving here. So, back in Ireland, I attended a small girls' high school in the west of Ireland. So I received the tuition that I needed to be able to cover the advanced curriculum for a higher level math because of the dedication of one teacher, that woman on the left there, who gave up her Saturday mornings to provide opportunity for a few girls. So opportunity made a difference to me then. She was the first person, other than my parents, of course, to say, you know, just go for it. So I did. By 1977, I was one of the 5% females in the graduating class of civil engineering in the University College Galway. That's the 5% in the middle photo. Now, at that time, the tallest building in Ireland was all of 17 stories, not quite 200 feet, and not quite the inspiration that you would expect for a future high-rise building designer. So after graduation in London, my first job was working on a Telford Gardens project in Hong Kong. This was my first introduction to real high-rise design. And I have to say that I did get a little inspired, and it was also a project which was over a transit rail station, over the Kowloon Bay station. That became a trend in my lifetime. It seems like I brought that with me all throughout my career. So within 5 years of graduating, I found myself in New York for 2 years. 36 years later, I'm still here. I'm thinking maybe I'll stay around for another while. But what was the magic that kept me in New York? I live in Hoboken. So you see these images here. There's a skyline from Hoboken. This is looking at Midtown about 10 years ago. And on the bottom, you see the skyline from Hoboken today. I feel really proud to have been fortunate to be involved in a number of the projects that are on that skyline. It's sort of a magic feeling. So what was the magic that kept me in New York? The city, its people, and its skyline fascinated that young engineer. The city also embraced me and offered up opportunities every day. So the young Irish engineer joins the Thornton Tomasetti diverse family, where I found an environment that really challenged me, supported me, and allowed me just to grow. I immediately worked on a tall building project, which was here in Chicago. It was called the Northwest Atrium building, and lo and behold, it was over a train track. Most of the time in those days, I was the only woman engineer in the room. But at this small and ambitious firm, what mattered most was what you knew and what you could do. Richard Tomasetti and Charlie Thornton fostered an atmosphere that encouraged innovation and risk-taking. The young guns, which at the time included Tom Scarangello and myself, were given enough rope to hang ourselves, and fortunately, it never quite came to that. So we moved along with an atmosphere that allowed us to take on what we wanted to take on and try to move the needle in terms of innovation in our professions. So this was my first high-rise building, okay, at 30 stories tall. This building is probably equivalent to a podium today on most of the projects that my partner Dennis Poon designs in Asia. So essentially, it wouldn't qualify as anything like high-rise. But this is how things moved in New York at that time and how things were happening in terms of the growth of the projects. At that time, we adopted the LRFD design, which was the newest in design technology, just hot off the presses. And I collaborated with my partner, Tom Scarangello, on computerized optimization for lateral systems of a steel core, using our mainframe computer and doing our runs overnight. So one of the things that is true about what we've been evolving as an industry, we've evolved with the analysis procedures that we've used. And when we were working back then, it was a matter of doing our basic analysis by hand and then using this mainframe computer to try to do our best to optimize. But in parallel with the core optimization, which was a structural optimization, I was sitting in conference rooms with Hank Brennan Beer Gorman, the architect, and his passion was for space efficiency. My passion was for structural efficiency. But what I learned there on my very first foray into the design of high-rise buildings, or slightly tall buildings, I learned the importance of true collaboration and that the best structure did not necessarily mean the best building. So that was something that told me very early in my career that it was a total collaborative process. I fell in love with New York City, with the kind of tough but tell it how it is attitude in the construction industry. Certainly no mutual admiration society, as I'm sure Larry will agree. The openness was and still is refreshing. What it does is it allows us to bring out the best in everybody, because there's no smoothing it over and taking second best. In the late 90s, there was a strong commercial market, high-rise market in New York Midtown, and especially around Times Square district. So there were several buildings that I was fortunate to work on with different clients. The Barclays building, 745 7th Avenue, the Ernst & Young building, which was in Times Square Tower, just across the street from the Ernst & Young building. And then a little later, the New York Times building. So all of these buildings had one thing in common. They were all steel. And this was the conventional wisdom in New York City, that commercial office buildings had to be steel framed. All kinds of lateral systems, from a core with outriggers for one, the next one was a perimeter modified tube, the third one a super diagonal exterior building, and then finally the New York Times utilized a combination because we were able to use some exterior bracing for the control of bracing for comfort and deflection control. They were exposed steel, and by the code, were not permitted to be used as part of the structural from a strength standpoint. There are things that we need to do in our codes still. Larry has told us, and I agree with him, that our codes have developed, and we probably have a lot greater strength and resilience in our buildings today than we did have before 9/11. It was a little bit of a wake-up call for all of us. But at the same time, there are lots of things that we can do in our code development to allow more fire engineering and better systems that will allow us to take the most out of every kind of piece of material that we have in the building. So my experience in London, Ireland, and my early years in the US, I worked on a lot of concrete office projects in, from Hong Kong, DC, Virginia, and from TT's experience all over the world and all over this country, we knew that concrete and composite buildings could offer benefits that a lot of other buildings systems, that all steel building systems might not offer. So it took a while to get the New York City real estate and construction industry to move off the dime and consider doing what has been done all over the world for quite some time. It would be the end of this cycle when we finally, I would say, kind of broke the mold, and together with Plaza Construction, designed this, this building here, which is 11 Times Square. And believe it or not, for people living in Chicago, you would probably not believe this. This was the first concrete core first building in a high-rise building in New York City, because union issues held us back. But it's an example of how slow our industry can be to embrace change. It required the owner and the designers and the builder to stick their necks out just a little bit and take a risk. It's not a risk of something that had never been done before. This was just a risk in terms of the availability of the workforce to do an efficient building, to build it safely, et cetera, in New York. And there were naysayers. There were people out there who really felt like it wasn't a smart move. But we engaged with the local unions. We brought them to Philadelphia, where we were building another building, which is the Comcast Center. And we showed them how buildings were being built safely there using this system, and convinced them that this is being done all over the world. Finally, they agreed to work within a system, and the project was successfully completed. This is not innovation, but this is sometimes what is necessary in the construction industry. The mixed-use tower, 731 Lexington Avenue, which is sometimes called the Bloomberg Building, this became the trend in the early 2000s or late 1990s, where the work-life balance in the city, people wanted to live in the city, and we ended up having a lot of these half residential, half commercial buildings. Building heights were growing in height, and damper systems became necessary to control accelerations in some of these tall buildings. Similarly, the Comcast Tower did need a damper system in the form of a tuned liquid column damper. Now, we all know that owners hate to spend money in several ways where they hate to see money sunk. One is in foundations, because nobody ever sees the value of a foundation. It's just there. Another one is dampers. No owners want to spend money on dampers. No purchaser or tenant can actually see the value in that either. But as structural engineers, we develop all the options to allow comparisons between tuned mass dampers, distributed viscous dampers, tuned liquid column dampers, sloshing dampers, everything, or just simply more brute force, more material, which may sometimes be the cost-effective solution. Our clients love to push us to make the problem go away or to minimize it. So I am thrilled with the Hummingbird damping system developed internally at TT based on NASA technology. We can now offer our clients an option that saves money and space, truly a developer's dream, while providing the comfort levels they expect at the top of a tall building. So you'll hear more about this in the innovation award sessions tomorrow, as it is one of the ones that is up for an award. So in between designing multiple high-rise buildings, and this is consistent with the time frame of 9/11, 2001, I was very much active with the Mayor's Commission for a New Building Code. We developed the codes and really tried to bring the level of high-rise building to a state that would be appropriate for the comfort and the security of people in New York City. It's something that really has influenced all of the major tall buildings that have been built since, and it continues to be a consideration when we are looking at tall buildings. We are after Sandy, we also had a resiliency committee where we developed the resiliency requirements for tall buildings, which is something else that is important in the city now. Recessions intervene sometimes, and a recession or a slowdown leads us to broaden our horizons and find opportunities in different places. It's certainly a pleasure when such opportunities bring you to places like Milan and Istanbul. Who could argue that it's not fun to do a project in cities like that? The Palazzo Lombardia, and followed by the Soyak Tower in Istanbul, opened my eyes to different issues and challenges. In Italy and in Turkey, the construction industries are equally set in their ways, as they are in New York City, and sometimes challenging the status quo is just as difficult. It becomes a mix of bringing some of new ideas to them and finding the collaborative partners there that will help you understand the local conditions and the capabilities. 2008 in Istanbul was pretty still fresh in everybody's minds, the 1999 earthquake. So the codes had not yet been developed to recognize procedures like performance-based design of high-rise buildings. But with the help of our San Francisco team, led by John Abruzzo, we developed the performance-based design approach for that twisting tower. And if you see at the base of this is a little bit of an optical illusion in that it appears to come down to almost a knife point. It doesn't quite do that, but it's quite a difficult building to design from an earthquake perspective. Certainly if you were following prescriptive codes, which was what they had in place at that time. But we were able to negotiate with the panel of professors in Istanbul to get the necessary approvals, and eventually, following that, 10 years later, TT continues to use performance-based design in many cities all over the world. Then back to the USA, and a detour for the Devon Energy Center in Oklahoma City, which was the first truly tall building in Oklahoma City. One was cognizant at that time that Oklahoma City had been the site of another disaster from the point of view of building collapse. And obviously, it was something that when you're putting up a really tall building in a city that has been through something like that, you have to be very much aware of it and be able to convince the powers that be, the owners and everybody else, that this would be a good and resilient building. And that was the approach we took. New York commercial, which really has been my life, commercial office buildings primarily, but residential buildings in New York have always had the norm is concrete flat plate, and that's what we do in New York. But there's not much about Via West 57 West that is considered the norm. The need to react quickly to changing geometry in the architectural schemes, that led us to use parametric modeling in the design of this iconic tetrahedral project. We even used parametric modeling to evaluate the impact of different geometry tweaks on the warpage of the exterior panels. So this kind of project brings out in your design the uses of new technologies. And that's one of the things that I feel is super critical. If we're not ready to embrace new technologies, we'll find ourselves like Blockbuster Video, would be out of business, and that's not a good thing for any of us. My partner, Tom Scarangelo, likes to talk about the ice business. The ice business went away when we got refrigerators. Blockbuster Video went away when we got our Apple TVs and our streaming. So we do not want to find ourselves in either the ice or the Blockbuster Video business. So what's interesting is that 30 years later, after my arrival in New York City, just about. I had still not seen designed, or I had not designed and delivered an all-concrete high-rise tower. That is quite phenomenal. Real estate brokers worried about the flexibility for their tenants. Local contractor market shunned the idea of an all-concrete tower, and this is a 900-foot tall tower. They really thought that concrete and post-tension concrete was not the right material or the right system. So it took an out-of-town contractor and a plucky owner to be willing to consider doing something that no other contractors would do in New York. We had designed a steel building. It was all the way through design development and probably 3 months from going for permit. And it then got turned around. It was a difficult negotiation with the steel industry. And I think that the owner said, "What do you think? Anya, come up, talk to us. What do you think about doing a concrete building in New York City?" My response was, it's about time. I was thrilled to have the opportunity, and we worked with the developer and the contractor, Perini, with Related and Perini, to put this together. Now, this was a learning experience for the local concrete market. It was not something that they had done or were used to doing or really not even particularly interested in doing, because all of the residential buildings are done flat. Flat place, simple, cheap, easy. That's not how you do typically long span construction in office buildings. So essentially, it was a learning experience, and now we're seeing more and more cast in place post-tension concrete in office buildings in New York City. Change is hard. Familiar solutions are safer, no question. And many engineers ask, what do I gain from pushing new solutions or ideas? One of TT's core values is we see opportunity where others focus on risk. That needs to be the mantra we use for the whole construction industry. The Harvard Business Review has judged the construction industry to be at the bottom of the innovation rankings. We need to do more to move the industry into the 21st century. For example, this could almost be last year, not quite, in terms of what has changed in the erection of steel in the last 60 years. Here you see two pictures, one from something like 60 years ago and one fairly recent one. I mean, the big difference here is you've got one has got safety harnesses and one doesn't, right? I mean, that's a good move. So we have made a move in the right direction. At least we have safer construction. But I think we can probably do more than that. Is that the only change we've seen? I think not too much has changed in the erection of steel high-rises, but there are maybe some pre-assembly, some modularization, which is catching on right now. But in the fabrication and shop, computerized fabrication techniques have been around for quite a while. But the whole industry has not yet taken full advantage of that technology. There is oops, that was back, this is forward. There is a process, a change that accelerates the design of construction timeframe, improves communication between the designer and the contractor, reduces errors, and significantly reduces RFIs and change orders. And we call that delivering the model. The way we at TT deliver the model is that as the engineer of record, we streamline the building design, connection engineering, and detailing into a Tekla model that can be used for fabrication. We deliver the model to the fabricator. I want to ask you, where is the logic in taking a 3D analysis and design and then converting it into 2D details on a drawing, handing it to a contractor and saying, okay, Now you figure out how to make it back into a 3D building. There's no logic there whatsoever. So innovation is not just about systems and materials. We can make a pretty big impact in our construction industry through innovating the process. Through stadium work with complex geometry, TT started using these 3D models for steel frame buildings 15 years ago and allowing the contractor to rely on the model. I introduced the concept to a developer client back in 2011 with a low-rise office building. And since then, the benefits of this approach have become more obvious. Sometimes impossible schedules are made more attainable by delivering the model. Larry mentioned naysayers. We have some naysayers that worry that the engineer takes on more responsibility and liability in this sort of a delivery model. I believe that engineers of high-rise buildings already bear an enormous responsibility, and maintaining continuity in seeing the structure through to the fully connected model reduces the potential for errors. So enter Hudson Yards, 30 Hudson Yards, probably the most challenging building on which I've had the opportunity to collaborate. It makes a difference to do this. 4 million square feet, complex, and the columns of this 1,300-foot tall weave and slope and twist their way down to the caissons below. I would just say competitive professionals look for a way to stand out from the crowd. I started with one major advantage. I was a woman engineer. I stood out from the crowd. I can wear a high-vis vest one day and I can wear an orange dress the next day. People remember me. I just need to make sure they remember me for the right reasons. But seriously, my hope is that the extreme gender imbalance that is limiting the potential of our industry today will have disappeared in the next 10 years. Diversity drives innovation. Let's engage 100% of our smart people instead of 50%. I rely on you to help me do this. And I want to thank all the collaboration with my clients and my multiple opportunities that I've been given throughout my career. I thank them for giving TT the opportunity to collaborate, and how lucky I feel to have been able to make some kind of an influence on our profession. So thank you to my current and former partners, and thank you to the Council for this wonderful honor today. And I hope that you all enjoy the conference. Thank you.